Today I'm going to show a quick demonstration about a difference in chemical and physical change. So chemical change, basically you're forming something new. So chemical change, you're going to form something new, a new substance, etc. There's four criteria I look at whenever I look at a chemical change. I look for a change in color, maybe go from colorless to red, blue, etc. Precipitate. Precipitate is a solid in chemistry. You say that I form a precipitate, you form a solid. Sometimes I look for bubbles being emitted. So like for instance, if you drop an antacid in water, you see all that effervescence, that means you're forming carbon dioxide gas. So anytime you form a gas, you've probably got a chemical change. You're probably forming something new. And then change in energy. Maybe you feel a bunch of heat given off or something getting cold, like a hot pack versus a cold pack. A physical change, you're not forming anything new. Basically, you have a change in physical state, like if you melt ice. Well, it's still water. You just went from a solid to a liquid form, etc. Or say you cut up aluminum foil, it's still aluminum, it's just in a different shape, etc. A good example or a good demonstration of a chemical change is that I'm going to drop potassium metal. So again, let me kind of adjust this a little bit. So potassium is a metal. When they say you need potassium, normally it's in the form of potassium chloride. That's an ionic compound. It's going to be a little bit different than this. But potassium is a metal. And with this metal here, I'm going to add it to water. Now, when you add it to water, you're going to see that potassium react with the water. So potassium metal is going to be stored under mineral oil. So this is oil. You can't expose it to the air very long, otherwise it's going to react with the moisture in the air. So I've taken out a piece of potassium. Again, this is pure potassium. It's not like potassium chloride or anything like that. I'm going to cut a piece of it. Again, you got to wear gloves for this kind of stuff. And notice it becomes shiny. What happens is the potassium is oxidized a little bit while it's in the mineral oil, etc. So let me kind of move this off to the side. And so what I'm going to do is kind of take a look at the color change that you see. It should be emitted a certain type of flame. That's going to be characteristic of the potassium. So I've shut off the lights and kind of see, if you can kind of see that the reaction, a little bit hard to see maybe on camera, whoa. But notice now, it reacted now with the water. It gave off a kind of a purplish color. That's the characteristics of it. Let's just do one more of this. Again, be a bit careful here. Hard to kind of see that violet frame. Okay. What had happened with this reaction was that potassium reacts with the water. And it gives off a purplish flame. So when you burn potassium, you give off a kind of a violet color. That's why potassium is used in fireworks. Same, like sodium will give off like an orange color, lithium a red color. So these group 1A metals will give off certain colors according when they're heated up, etc. You see kind of a cloudy substance in there. That's potassium hydroxide. That's a precipitate, actually. So you see kind of a solid in there. It gave off a lot of heat. In fact, what happens is, what caused that reaction to flame up is that it produced hydrogen gas. This reaction is exothermic. So exothermic gives off heat. That heat ignited hydrogen gas. So hydrogen gas is very flammable. That heat produced by the reaction, exothermic reaction, caused that flame, caused that potassium to burn. That's why you saw that flame with that. It was hard to see some bubbles. If you look closely, you may have seen some bubbles. But again, it was on fire, so you want to be a little bit far away from that. So again, this reaction, you saw a color change. You saw purple being emitted when the potassium burned. That's characteristic of a chemical change. You saw a precipitate, that's that cloudy substance in there. You saw a change in energy. You saw that be an exothermic reaction because the heat was given off when you're doing that. Again, that heat caused that hydrogen gas to ignite. And then it was hard to see the bubbles, but with hydrogen gas forming, you probably saw some light bubbles with that. So just to finish off, I wrote a balanced chemical reaction for this. So this is potassium, that was water. Those were our two reactants. This is stuff we started off with. Again, yields now, potassium hydroxide, that's a kind of a cloudy white stuff, a little bit hard to see inside that beaker, and then hydrogen gas being formed. So again, a couple of things. These are the reactants, and then these are our products. Again, this is a good example of a chemical change. You don't need to see all four to have a chemical change. Normally, 1 of 4 criteria is going to be good enough.